Hey everybody, this is Larry. This is day 26 of the Leetcode, or 27, sorry, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Everything is chaotic today. My marathon is in less than 12 hours, so I'm going to try to rush through this, get some rest. My mountain is very messy, that's why I'm kind of rubbing it. My apologies. And I am whispering a little bit because I am, again, in my friend's place, hosting meet, and it's getting late, and yeah, don't want to wake people up, so my bad. But let's take a look at today's problem. Let's get really quickly and let's figure it out. Okay, so I'm not going to read the problem. We have 1277, count square submatrices with all ones. Okay, so they have to be square. Okay. Yeah, I mean, this one is I think and I'm speaking a little bit closer to the mic so you could hear it, even though I'm whispering, hopefully. But this one is, I don't think this is an easy problem per se, or I mean, I know that they grade as medium. I think it's kind of harder if you haven't seen or few some similar things before. But the idea is just dynamic programming, right? And the idea behind that is that, okay, you have, how many 1 by 1 squares do you have, right? And then how many 2 by 2 squares do you have? They kind of hinted at example, but 2 by 2 is made out of 4 1 by 1s, right? In a certain pattern, right? I wish I could draw it out, but maybe I'll draw an SKR, right? But basically, you have a 2 by 2. It looks like this, right? 4 1 by 1s, that looks like this. 3 by 3 is made out of 2 by 2s. Right, but 4 2 by 2s in a particular way. Maybe I'll try to fingerprint or finger draw the printing thingy. Hang on, let me set this up. I know I'm rushing it a little bit, so my apologies. I'm trying to go to bed really quickly. But basically the idea is that, okay, let's say you have something like this, right? Again, I'm on the touchpad, so pretend it's good. But you have 4 of them that looks like this. 1, and I know they're more circly so you can see it, but 2, 3, and 4, right? So you have 4 2 by 2s that made up 3 by 3. So in that way, you can kind of see by defining it in a particular way. In this case, you can define it by, say, the lower right corner, right? So let's say here, this, you can say that this is the right lower. Let me change the color real quick. Actually, you can say that blue is not very visible. You could say that this square is the lower right of a 2 by 2 that ends here, right? And then now, if you have one of this here, you have second one here that's over 2 by 2, third one here, and a fourth one here. Then now you have a 3 by 3. You could kind of I mean, I know I'm rushing it again, but basically through this idea, you can build up a 3 by 3, obviously. But using 3 by 3s, you could build up a 4 by 4 in a similar way. So that kind of idea is how I would start to think about it, right? So then now, here the dynamic programming is going to be very quick, right? So then now we and then now for each lower right corner, we can figure out what is the maximum, the biggest square, size squared that ends with that as the lower right corner, right? So that's basically the idea, and then just sum it all up together. And yeah, so let's just say we have 0 times right, and then now for x and I and j, maybe that's square, right? If matrix of ij is equal to 1, then now dp of ij is equal to at least 1, right? And then now you think, okay, what is the biggest square on the upper left, on top and to the left, right? So then now you can say something like is equal to max of 1, which is itself, I suppose. Maybe that looks a little bit funkier. And then of I minus 1 j, oh, not max, sorry, well, max of this, but min of the other ones, right? Because you have to combine 3 of them and the current thing, right? Because basically we have a, let's see, we have a 2 by, if the max is 2 on the upper left, 2 on the left, 2 on the right, then it is going to be just, then now you have 3, right? So then now this should be actually just this plus 1, right? And of course, this maybe goes out of bounds, so you have to do a little bit of magic, but that's really basically the idea. So now it contains the size of the biggest square where it is the lower right? And of course, and actually the fun thing about this, which you can see it as summing up, is that if the biggest size is 3, actually the 3 squares that has the lower right as the square, right? Because you have one of size 1, one of size 2, one of size 3, one of size 4, and one of size k, right? Or whatever the number is. So therefore, that's why you see things that you can do something like this. And that's pretty much it. I mean, we have to handle this case, but yeah, like we'll make sure that if this is greater than 0 and j minus 1 is greater than 0, I think that's pretty much it. And yeah, maybe there's some edge cases, but honestly, I'm rushing a little bit. I am trying to get to bed, so let's do a quick submit. But I did it 3 times, or this is my 3rd time. We have a 71-day streak, but that's all I have for this one. Thanks for watching. Stay good, stay healthy, keep your mental health. I'll see y'all later and take care. Bye-bye. Wish me luck on the marathon tomorrow. Sorry that this is a little bit rushed, as I say, but I need to go to bed, and we'll see what happens. But one more thing before I go, as I always say, and as I've been saying this training session, right? Tomorrow is just the expression of all my training. It is not like, if I didn't train, it doesn't matter what happens tomorrow. And because I trained, it also doesn't matter what happens tomorrow, because I am the sum of my training, not just one race. And I'm not like training for the Olympics or something like this, right? Like, it doesn't really matter. It's just for myself. So anyway, we could talk about it more when I'm not whispering. So thanks for watching. Stay good, stay healthy, take good mental health. This is a weird session, but when I get back to New York, we'll chat more. I'll see y'all later. Take care. Bye bye.